Greetings, welcome to this video. So we're dealing with set builder notations, and we have a problem here that has been given to us. So we want to be helped, or rather see how we can solve this kind of a question. So we're given set builder notations, and we have to list the sets or the elements from those sets. So the question says, let the universal set of U be, so we've been given a set builder notation that defines the universal set, and the universal set has been denoted by U. And usually it is the case. Most of the times when they're talking of the universal set, they will denote it with U. Now, we're being told to say x is such that x is less than 11. So we understand that the numbers in the universal set, or the elements, are less than 11. Then the same x is a member of natural numbers. Another thing we should take into consideration, natural numbers. So what are natural numbers? Natural numbers, basically, for us to answer this question, we need to understand them. So when you talk of natural numbers, you're talking about the positive values or integers that start from 1. So when you talk of natural numbers, we mean the numbers will start from 1, 2, 3, straight up to infinity. So 0 and negative numbers are not part of natural numbers, and they are whole numbers. So we don't have fractions or decimals under natural numbers. So we are being told to say x is less than 11 and x is a natural number. So this puts a confinement to say the values of x are confined within natural numbers. So we've also been given the set A, 1, 2, 3, 4, 5, set B, 4, 5, 6, 7, set C, 5, 6, 7, 8, 9, set D again, we have another set builder notation. It says x is such that x is equals to 2k plus 1. Again, k is a member, or k is a natural number. But it's good at this point because we've already talked about what natural numbers are. Then we've been given set E, another set builder notation. X equals to 2k. Again, k is a natural number. And finally, we've been given set F. F consists of 3 elements. That's 1, 5, and 9. Alright, now let's answer our first question. Our first question says, list down the sets U, D, and E, given that D and E are subsets of U. And in the question, we're told that U is the universal set. So meaning D and E, they've been driven from the universal set. Now we want to list the set. So we'll start with U. We're going to start with set U. We'll start with set U. We want to list the set. So remember to add braces. Yeah. So yeah, you need to put the elements in braces. Now, set U, remember the set builder notation on set U. They're saying x is such that x is less than 11 and it's a natural number. So go into a set of natural numbers and list those which are less than 11. So start. The first one will be 1. Okay, let me list them then. So this will be a set, or this will be our universal set. So notice that the elements, all the elements here, are natural numbers, but they are less than 11. So this is what was defined with this set builder notation. This is what we needed to come up with. Then we're told to also list D. So D been given in the form of a set builder notation. So what that means, we need to define it. They are telling us that the element x is such that x is 2k plus 1, where k is a member of natural numbers. Now, the same k is confined within natural numbers, and is a since set D is a subset of U, meaning we'll just consider the elements here. So k will be defined within these elements here, right? And the elements, the set D shouldn't be greater than the universal set because it's been driven from this. So if we plug in a number in this set builder notation that we've been given, since they're telling us k is a natural number, so if we pick one natural number, we'll start with the first natural number. From within the elements in the natural numbers. So okay, let's do this. Think of any natural number, but whatever values that we're going to have should not go beyond our universal set. So start with the first one, which is 1. When you plug in 1 where there's k, we're going to have 2 times 1, which is 2, plus 1 here will give us 4. Sorry, 3. So 2 times 1, which is 2, plus 1 will give us 3. So we're going to have our first element for what is D as a 3. Then we go to the next one. We plug in 2. 2 times 2 is 4, plus 1, 5. And it goes on like that. So you should have something like this. Yeah. So why have we ended on 9? So you notice that when we plug in 4 here in this, we're going to have 2 times 4, which is 8, plus 1, it's 9. Then when we try to plug in 5, we're going to have 10 plus 1, which is 11. It's going beyond the universal set. So our set D will end here. Let's proceed with set B, with set E. So set E, it's also been given in a form of a set builder notation. Now they're telling us that x is such that x is 2k, just 2k. So we'll plug in the values of k to find the element. So again, we'll start, it's confined within natural numbers. So start with the first one. So if we plug in here the first natural number, 1 into this set beta notation. So we're going to have 1 here where there's k. 2 times 1 is what? 2. So 2 will be our first value there. Then we do the same for all these remaining elements. Yeah, so it will end on 10, because if we plug in 6, we'll go beyond our universal set. So this shows that these two are simply subsets of this. They've been picked from this universal set. So this is how you list the sets U, D, and E. So remember that all these elements were confined within natural numbers. So the key thing here was for you to understand natural numbers, or is for you to understand what natural numbers are. Then you can go on and simplify the given set builder notations. Then we've got another question here. Question B says, find A intersection U union C. You remember those laws we talked about in the earlier videos? If you haven't watched, then I'll leave the link in the description. The commutative law, associative law, and all those. Now, it's fine even if you did not watch those videos. So the question says find A intersection C union E. So what we're going to do, the first thing that we're going to do is to bring down what set A is here, because intersection means what is common between the two. So we need to see what's in set A and what is in set U union C, then find what's common between these two sets, then list them. So let's write the two sets down here. So I've listed this is set A and this is set C union A. Now I think let me also explain here how I have this set. So C union C, it means you're getting elements from this set C and the set that we've listed, set E. So you're putting them together. So you start with the lowest. We have 2, 4, then we've got 5 in here, 6, 7, 8, 9, and also 10 here. Then you make them as one set. Then just find what's remaining for you to find what's common between these two sets. So if you look at these two sets, 2 is in this set, 2 is also in this set. You also have 4 in this set and in this set, 5 in this set and in this set. So we've got 3 values that are common, and you write them as your A intersection C union E. This will be your final set. So basically these are not some things that okay, they are direct things. What is required is for you to pay attention to the sets that we've been given and how the set builder notations have been defined. So in the next video, we'll start from the next question and solve these two questions. Alright, thank you very much. Remember to subscribe and also hit the notification button. This was a viewer requested video from a student at the NRDC. So thank you very much.